Hi, Assalamualaikum. We are from MEMS 17. Our team members are Muhammad Hafiz, Muhammad Izzat, Nurul Syafiqah, and my name is Amir Shahmi. So, the device that was assigned to us for our project is MEMS Piezoresistive sensor.
For the MEM piezoresistive sensor, the operating principle of a design of MEM piezoresistive pressure sensor is four resistors placed on a silicon diagram in order to measure the result of strain of physical pressure applied upon them. The formation of a displacement equation is the equation is D equal to 0.01512 in a bracket 1 minus V power of 2 PA power of 4 divided by EH power of 3. For P is applied pressure, A for a side length of a diagram, E stand for Young modulus of a silicon, H stand for thickness of a diagram, V for Poisson of ratio of silicon. So the output of voltage equation is V output equal to P A power of 2 in bracket 1 minus V V2 pi L and multiply by V in divided by H power of 2.
MEMS fabrication simulation. This is our layout of piezoresistivity pressure sensor. First diagram is viewed from the top, and the other are diagram of each layer of pressure sensor. Descriptions of each layout has been stated based on the table on the right side. All the shapes of this sensor are the box. Below are the material database. We use 4 materials, which are polysilicon, monosilicon, boron, and aluminium. Elastic moduli, Poisson ratio, density, thermo-expansion coefficient, relative permittivity are the properties of material for this sensor. Next part is process definition and 3D model. Process that includes are deposition and etching. There are 8 steps for this process. First, polysilicon as wafer. Second, monosilicon as wafer. Third, boron implantation. Fourth, wafer bonding. Fifth, aluminium deposition. Sixth, aluminium patterning. 7, polysilicon etch. And 8, the final one is substrate etch. We define gray as monosilicon, red as polysilicon, green as boron, and yellow as aluminium. Diagram below shows the 3D model and the final cross-section of our sensor.
Okay, for our MEMS finite element analysis, the analysis system that we use in this project is static structural. As we can see, there are 7 steps to complete the finite element analysis. For our geometry, the design was built in the space claim. Instead, we import the design. Move on to the model step. We just use only the default mesh. And then as for our input, we assign pressure from the bottom of the diaphragm, as we can see the red region one. And then we assign a fixed support around the edge of the input area as the boundary condition. And then for the output of our project is the total deformation. Okay, so this is our output analysis, which is the output is total deformation. As we can see on the graph, the total deformation is proportionally increased with the pressure value that assigned, which is 10 until 50 Pascal. Then there are 4 different materials that we use as for the diaphragm, which is polysilicon, germanium, silicon dioxide, and silicon nitrate.
Okay, for the campus sustainability, a water storage tank is exactly what its name implies, a humongous tank made of concrete primarily used to store water. This water may be used anywhere inside the house for doing chores like laundry and doing the dishes or flushing the toilet. The service providers as WT Syndrome are also launching in order helping owners to make their home office and school or university more efficient in order to supply sufficient water to the staff and students. Okay, next, for the United Nations Sustainability Development Goals, we use SDG 6. There is clean water and sanitation. Okay, for that, the shortage of water is a common problem that the student needed to face every month. Improper water management meant the supply water to the community will affect their daily life. A smart water management is proposed by utilizing a MEMS Piezoresistor sensor. This smart city solution will create a higher efficiency in terms of resource and cost associated with keeping the water will flow smoothly with the good pressure. Okay, SDG 6 focus on ensuring a clean and stable water supply and effective water sanitation for all people by the year 2030. The goal is a reaction by effect to the fact that many people throughout the world lack this basic service. About 40% of the world's population is affected by a lack of water. Okay, then installing piezoresistive sensor to the water tank is the ability to supply the water smoothly met the pressure with good condition. With this device, the water efficiency in campus can be improved. Okay, that's all.
Okay, that's all from us. Thank you.